Welcome to the lecture on plug, mixed and dead regions in tundish. So, we talked about the tank and series model. So, tank in series model, and apart from that we also have. So, in that tank in series model we had seen in the last class that it's for the case that a series of well mixed tanks will be giving the response curves, and it will be similar to the dispersion model. Then you will have the C curve by well mixed for the well mixed tank, and variance of the curve is taken as 1 by n. So, it is what similar to somewhat in the for the dispersion models. And when you take the large number of tanks, then in that case the C curve become increasingly symmetrical. So, that is what you have seen for the tank in series model. Now, apart from that, you have the combined or mixed models also. So, in that case what you see, what you do is that you are getting basically the different zones in the tundish. So, there are models, that is combined or mixed models, in which the fluid volume in the vessel is assumed to be consisting of interconnected flow regions. So, that will be in that case you are thinking that it is a tank which is interconnected in series. But in this case what we see that you will have the interconnected flow regions in the vessel. So, mostly it has been seen that you will have 3 kind of flow regions which will be present inside the vessel. One is the plug flow region, another is well mixed region, and the third is the dead region. So, plug flow region and the well mixed region, they are known as the active region also. And if you talk about the other region, that will be dead region, which is not active in one sense. So, what happens that plug flow you can we can have the idea about these plug flow. So, what happens that when you have the if you have the concentration here, and this is your theta. So, this is concentration and this is theta. So, what happens that if there is no mixing taking place up to certain time, no dispersion taking place, and then after that the mixing has become effective. So, in that case if your mixing starts from here. So, in that case this region is the representative of the plug region. So, and then this becomes the mixed region, that is well mixed region. So, as you see that here there is it is a straight jump and then it is coming here. So, it becomes like a well mixed zone, and this becomes the plug zone. So, plug zone is there, and then you have the well mixed zone. Then also you have the definition about the even the dead zone. So, the plug zone and the well mixed zone, they are normally known as the active zones. So, what happens that if you draw the C curve for the combined model, where we have the combined zones which are available. So, what happens you have here from here it will go like that. So, this is the maximum concentration, that is C max. So, this is what you are getting that is C max, and this C max is the inverse of the mix volume component. So, that is normally we will be V upon Vm, and this amount, this will be basically indicative of the plug zone. So, so this is known as the theta mean. Theta means this is the time at which there is first appearance of the tracer is seen. So, what happens that when you have a tundish and suppose you have different outlets on both these sides, and this is your inlet, suppose. So, inlet after coming here, it will go like this. So, it will come here and then it will come here. So, similarly it will go here first and then it will go here. So, it will be going first to on these two sides, on these two outlets, and then later on it will be going on these two outlets. So, the appearance of tracer, suppose for this outlet may be after only 5 seconds, whereas the appearance of this tracer at this outlet will be maybe 25 seconds. So, that 5 second and 25 second will talk about the plug zones or so. So, when more appropriately you can say that when you have only one outlet, then in that case you can say that when it is first appearing at the tundish outlet. So, that way you will have this is as the theta min, that is the time at which it is first appearing, and as we know that integral of c d theta will be normally 1. So, your area becomes 1 here in this case. So, and this is time theta and this is your c. So, C max is V by Vm, and what you see is that this line can be having we will be having that expression. So, this will be having a can be represented by this function, that is V by Vm exponential of minus of V by Vm, and in bracket it will be theta minus Vp by V. So, that way this is how this this graph can be represented. Now, coming to the these two regions, basically you can define them as the two regions, like you have the active region as well as the dead region. So, once you talk about the active regions, so active region will be the region which will be represented by the plug region as well as the well mixed region. So, combination of plug region, so plug flow, that is or plug flow, you can write plug flow where it is taking place, plus you have well mixed flow regions. So, this gives give rise to the active region. Now, active region is basically that region where fluid particle is going, and through that region it is passing, and if there is any region where the fluid particle is not going, or if it is going and it is getting its appearance from there is at a very late time. So, in that case those regions are said to be the dead regions. So, as we see that you will have this plug region, and you will have the well mixed flow region and the plug flow zone that will be related to the time at which the tracer first appears. So, and then you will have the peak that will be inverse of that well mixed volume. So, that way you will have the representation of these two plug flow as well as the well mixed flow. If you come to the dead regions, so apart from these two regions you will have the dead regions. So, if you take the tundish volume, so if you say plug volume and if you have the well mixed volume, so the difference of the whole tundish volume, if you take the subtract these summation of the plug and mix, so that will give you the dead region. So, in the dead region means that the metal, I mean it is not participative, that region is not participative. So, you will have you may have two types of dead regions. Now, there may be region which is completely stagnant. So, you may have the completely stagnant region. So, the fluid will will be moving very slowly, and the fluid remains in that vessel in that vessel for a very much longer time. So, so what happens that you will have to have one criteria that what should be the time if the liquid stays, if the particle stays for more than that time, then it may be called as the dead region. So, normally some of the authors have taken 2 times the theoretical mean residence time, some of them you may take even the 3 times the mean residence time. So, accordingly you measure the the dead volume, and you classify the dead regions based on that volume component where the time spent by the fluid particle is more than, suppose say 2 times the theoretical mean residence time. So, that way we compute these dead regions. So, you can have also the in the definition, like when the fluid particle stays for more than twice the theoretical mean residence time. So, accordingly you can have the definition of these dead regions. So, if you look at a typical C curve, so suppose you have such kind of the C curve. So, this is C and this is your theta. So, suppose this is your this becomes the, so if theta is there, so say suppose 1 and this is your 2. So, the liquid particle which is staying more than this 2 times. So, this region can be said to be the dead region. So, and you will have active region as well as dead region. So, this region becomes the active region, whereas this region will be shown as the dead region. So, if you have, suppose if you see that your if you are taking the 2 times the value as the one after which you are categorizing as the dead region. So, suppose the mean of the C curve up to cutoff point of theta equal to 2 be theta c. So, suppose it is theta c. In that case theta c will be, so this will be measured Tc. So, that is what you have measured, and then that will be divided by the mean residence time. So, that way you measure this theta c. So, theta c will be Tc bar upon T bar. So, if you take the theta c, it will be Tc bar upon T bar. So, it will be Va Va upon Qa, and that will be divided by V by Q. So, that is A is for the active region and Q is the flow rate. So, you will have the active volume, and this is the Q for the flow rate. So, accordingly you will have so it will be having Va upon V into Q upon Qa. So, Va by V can be Qa by Q into theta c bar. So, you can have the calculation of the dead volume. So, dead volume will be nothing but the 1 minus the active volume component, that is Va by V. So, if you have the to find the dead volume fraction, so dead volume fraction will be Vd by V, and Vd by V will be 1 minus VA by V. So, it will be 1 minus QA by Q into theta C. So, that way you will have you can calculate the fraction of the dead volume in if you have the RTD curves with you. Now, this QA by Q term, this will be this will be representing. So, it represents area under C curve from theta equal to 0 to theta equal to T 2, that is you have taken as the active region. So, that will be from theta equal to 0 to theta equal to 2. So, if you have so after that that region will be the dead region. So, for them if your dead region is completely stagnant. So, because there may be dead region where the fluid is not at all flowing. So, that will be completely stagnant. Then your volume is basically effectively the volume is reduced. So, you will have the effectively the volume will be reduced to VA only. Effective vessel volume will be only VA. So, that VD part is completely unutilized. So, if you have suppose a tundish and your this region is completely this is here which is completely stagnant. In that case effectively you have only this is the so this is only the VA. So, so that is another aspect of the dead region. So, that tells that so that is why we try to have the minimization in the dead regions in the tundish. So, because that will be a loss to the productivity of the tundish. So, dead volume fraction with if you talk about the for the tundish. So, the dead volume fraction you can also have you can. So, QA by Q if you look at. So, in that case QA by Q will be normally equal to unity. So, that can be VD by V will be 1 minus theta C bar. So, in the case of stagnant system you will have 1 minus theta C bar. So, that way you will have the calculation of the VD by V in such cases. So, you can have the different kind of tundish furnitures. You can have the there may be use of flow modifiers to alter the flow behavior in the tundish. So, that you can decrease these dead regions. So, that is what the aim is in the tundish, that you should have the minimum of the dead region inside the tundish. So, one is so that can be if you look at the C curve you will have a long tail that is going on. So, that also is one of the representative of the dead zone, whereas so some of the zones where it does not go even and that is completely stagnant. So, that is also part. So, the anyway that volume itself is not being utilized. So, for that what is being done is normally you have if you look at the situations like if suppose you have inlet from here and you have outlet from here. So, what is done if so in normal case when the flow will come. So, it may go like and it will be coming like this. So, basically all these zones all zones become sort of dead zone. So, either they do not take part or if it goes it comes very slowly. So, once it will go this will have very small velocity. So, slowly it will come and it will have a very long residence time inside the tundish and then it will be coming out. So, what we do normally that we use these tundish furnitures. So, many a times what we do you have inlet from here. So, we use the different tundish furnitures like here then you may use the dam here. So, what happens that the metal which goes, so it will be coming up and then it will be moving in this direction. Now, from here it will move like this, and if suppose it is of this height, so from here it will go to into even this direction, and then from here it will come out and you have outlet here. So, if you what you see, you have in this case you have many zones, all these zones which are like a dead zone, and when this zone comes like a dead zone. Now, you can see that by the use of these tundish furnitures like dams or weirs which we use, you are effectively utilizing all these places. Now, what may happen because of the dead regions? So, in those cases, if it is not, the fresh steel is not going, that may give rise to the decrease of temperature, and many a times it becomes stagnant, and then there may be the solidification also taking place in those regions. So, that may be harmful in such cases. And if you look at these two situations, so what you see that the whole of the volume of the tundish is being utilized for the metal to flow. Now, in this case also your theta min, so in this case it is so the theta min that is appearing, so that also is being increased. So, your plug volume also is basically increasing that way. So, you can have some equations you can use for the calculation of these volumes, like you have the plug volume. So, Vp by V, that will be theta min. So, what you do is normally when you get the time and concentration values, so you will draw the time concentration plot. You will be getting the theoretical mean residence time, that will be volume by volumetric flow rate. So, so that will be used for finding the dimensionless time. So, the all the time will be divided by that dimensionless time. So, you will have that is mean residence time. So, you will have the dimensionless time theta on the x axis, and on the y axis, as you see, you will have the q by v. So, that way you are dividing, and then you are getting the concentration, dimensionless concentration value on the y axis. So, the Vp by V will be theta min. So, wherever you are getting the theta min value, wherever the so suppose here it is coming, and if suppose theta is this is theta and this value is 0.0, suppose say 5. So, it may come like that. So, it means 5% we call it as the plug volume. Then you will have the calculation of the dead volume. So, dead volume, as you see that you calculate by seeing that which of the how many, where the theta is more than 2. So, that you will have the calculation of the dead volume, and once you have the calculation of the dead volume, then you have the well mixed volume, and that will be 1 minus Vp by V and minus Vd by V. So, that way you calculate. So, you will have the mean residence time coming in actual, and based on that basically so for the 2 theta values you can calculate the residence time, and then you can have the fraction of the dead volume. So, that will be dead region, and the plug region. So, accordingly you can have the calculation of the well mixed zone in that case. So, so that way your different different component of the plug region, then mixed well mixed region, as well as the dead region is being found out. So, you can we can understand like if suppose if you try to have the solution of a certain problem. So, what you do is you have a typical you may have typical residence time. So, and then one is that you have the area under the this curve has to be unity. So, your area under the curve has to be unity. So, what happens that so you have theta equal to 0 to infinity, and you have C I delta theta, that will be 1. So, you will be calculating the mean residence time of the whole curve. So, mean residence time for the whole curve, that has to be so theta bar. So, that you will have theta equal to 0 to infinity C I delta theta, and divided by theta equal to 0 to infinity C I. So, that has to be basically 1. So, we are calculating the mean residence time up to theta equal to 2. So, for that you will have the theta c. So, suppose you are taking the mean residence time up to theta equal to 2. So, you will have theta c. So, that will be computed, and that will be summation of theta equal to 0 to 2, and that will be C I delta theta, and then you will have summation of theta equal to 0 to 2, that will be C I. Now, the thing is that if you so that is done for the curve which we had earlier seen, where you had the data that was there, where we have suppose you get the curve like this. So, you will have the C values, and then you will have like 0.2, 0.4, 0.6, 0.8, and so. So, and then on this side you will have 1, 2, 1, 2, 3. So, this will be, so at this it will be that is taken for calculating the actually the dead volume calculation. So, if if it is so for this problem, when you computed this sigma C I delta theta upon sigma C I, so it came as 0.857. So, 0.857 is coming as the theta c prime, and that is why your if you neglect this q by q term, in that case the dead volume will be 1 minus 0.857. Suppose for this problem it is coming as so that can be computed when you have the c and theta value. So, suppose it is coming as 0.857. So, in that case it will be coming as about 14.3% as the dead volume. And if suppose you are having the area of the curve. So, if you take that curve, and if you take the area of the curve up to theta equal to 2. So, you will have the based on that also you can calculate these QA by Q values, and that may have some different value. So, and then you can also calculate the dead region maybe Vd by V. So, that will be again 1 minus your theta c. So, if you take QA by Q into account, so in that case that may be even later. So, that can be understood when we solve the problems. So, when we take one example. So, suppose you do the experiment and you have these data. So, based on that you can calculate these different volume values of the suppose say plug volume, mixed volume, as well as the dead volume of the tundish. So, this is about the calculation, and we can further discuss in our when we will talk about the analysis of the cases. In that case, we will be seeing that how the different kind of curves are generated and how these curves are different when we use the flow modifiers and how we calculate these different tundish volumes. Thank you very much.